Let's start off with absolute value. The key thing to know is that absolute value is really a piecewise function. The absolute value of x means that when x is less than 0, we're really talking about negative x, the opposite of x, because if we have a negative number and we make it positive, that's just the opposite. However, if x is positive, so that means when x is greater than or equal to 0, 0 isn't positive, but really this equal sign could go in either location because negative 0 is the same as 0. But when x is greater than 0, this positive number stays positive, so it ends up being the same thing. It ends up being that x. So the first thing we want to be able to do is write absolute values of piecewise function because we know how to deal with piecewise functions. To do that, to write absolute value as a piecewise function, first find the x-coordinate of the vertex, i.e., or another way to say that is the number for x that makes the quantity inside the absolute value symbol be 0. Then, for all x's that would normally make the inside function negative, use the opposite function, the opposite function is negative 1 times the function. The rest of the time, use the same function as the original. So let's look at an example. We're going to write absolute value of 3x minus 6 as a piecewise function. So the first thing we want to do is find the vertex. So we're saying what value for x makes 3x minus 6 equal to 0. Add 6 to both sides, 3x equals 6, divide by 3 on both sides, x equals 2. So what we really have here is we have a little v shape, that's the absolute value. And when x equals 2, that's where that vertex is. So, absolute value of 3x minus 6 can also be written like this. We're going to find this number where the vertex is, so this is 2. So our top piece is going to be for x is less than 2. Our bottom piece is for x is greater than or equal to 2. Again, the equal sign can go in either place. Let's put it down here for convenience. And notice that the function just plain old 3x minus 6 has a negative x-intercept, a negative y-intercept down here at negative 6, and a positive slope. So really we're talking about this little part right here. So when x is greater than 2, we're just using exactly what was originally inside the absolute value. However, when x is less than 2, 3x minus 6 is going to be less than 0, basically continuing this line right here. But since we have the absolute value sign, this is going to take this and sort of reflect it over the x-axis. It's going to make it into this positive piece right here. Notice that this has a negative slope and a positive y-intercept. It is the opposite function. It's negative 3x plus 6. So this part right here is what's inside the absolute value. And this part up here is negative 1 times what's inside the absolute value. And this is because in this section of the graph, because this value is going to be negative, the absolute value is making it the opposite, so it's doing negative 1 times what's inside. So let's check your understanding with a second problem. Write the absolute value of x plus 2 as a piecewise function. Go ahead, pause the video, try that on your own, and then start the video again when you're ready. Okay, the first thing that we're going to do is find the vertex. X plus 2 equals 0, x equals negative 2. So we're looking at something like this. Then we're going to write the function. Absolute value of x plus 2. Negative 2 is our vertex, so we're going to do for x is less than negative 2 and for x is greater than or equal to negative 2. And over here we've got a positive slope, positive y-intercept, so it's the same thing, x plus 2. And this one is the opposite function, negative x minus 2. We can see this is a negative slope. It's going to have a negative y-intercept. To work with absolute value and differentiability, write absolute value functions as piecewise functions. P-I-E-C. And after that, you can just do what you would normally do. So, for example, is absolute value of x plus 4 differentiable at x equals negative 4? Now, if you know your parent functions and you know the shape of this and you know your transformations, you know that it's a V shape with a sharp turn at x equals negative 4, and so it's not differentiable. But even without knowing the graphs, if you just split it up and write it as a piecewise function, it'll be fine. So let's write it first. Absolute value of x plus 4. And so we're going to find the vertex. X plus 4 equals 0, x equals negative 4. So 4x is less than negative 4, 4x is greater than or equal to negative 4, x plus 4, negative x minus 4. So to check for differentiability, we first have to check for, is it continuous? Limit as x approaches negative 4 from the left. We're going to use the left function, negative x minus 4. So we just plug in negative 4 that equals 0. And then the right limit and then the value, so absolute value of negative 4 plus 4 equals 0. Yes, it's continuous. Left limit equals right limit equals value. We do still have to check though, is it differentiable? Here's where it's very useful to have this already separated right here, because now we can see the derivative of the absolute value of x plus 4, negative 1, when x is less than negative 4, positive 1, when x is greater than or equal to negative 4, limits x approaches negative 4 from the left, it's negative 1, limit as x approaches negative 4 from the right, it's positive 1, not differentiable. They don't match. The same thing can be done if the absolute value is already part of a piecewise function. So let's look at, is f of x, which equals absolute value of x minus 2, for x is less than 2, versus x minus 3 squared minus 1, for x is greater than or equal to 2, differentiable at x equals 2. Okay, so the first thing that we want to do is we want to rewrite that absolute value. We know x minus 2 is going to equal 0 with the vertex, x equals 2. So this is x minus 2, this is negative x plus 2 right there. Now notice that we're only interested in this for x is less than 2. So that means we're only going to use this piece. This part is over here. When x is greater than or equal to 2, f of x is defined differently. So we don't need to use this part at all. We just need to replace this part up here with that. So this means f of x actually equals negative x plus 2 for x is less than 2. And then the other piece here, x minus 3 squared minus 1 for x is greater than or equal to 2. The rest of this can just be done like normal. Go ahead, pause the video, do that one on your own just to make sure that you're really solid with it. I'll have the answer as soon as you start the video up again. Okay, here's the answer. First we looked at continuity, left limit, right limit, and value. Those are all 0, so it is continuous. When we take the derivative, this is what I get for the derivative. Plug in 2, left limit, right limit are not the same, negative 1 and negative 2. Since they don't match, the function is not differentiable.